Welcome in, guys. Thank you for coming in. We're gonna flip the camera. So what we have, guys, we got an applied math problem. So we're gonna spend a few minutes doing some applied math problems. Okay. So we'll wait for a little bit to do some applied math problems. All right. Oh yeah, we gotta focus. Yeah, make sure the camera focus. So come on in, guys. Once you come on in, that'll be our props. We're gonna do some applied math problems. I think I'm a little bit too high on this chair. No substance, guys. Just talk about the chair. Trying to keep this at eye level. Went to room warm up. Work on a couple of problems. Man, I'm gonna go outside today. It's hot. So, guys, if you guys are taking chemistry, we're gonna get started. If you guys are taking chemistry, Chem 101, and our goal is to add up the elements here, and we want to get the total number of grams. So each of these have been weighted and scaled, and so it's on a periodic table. All we have to do is read the numbers, and just get those numbers from the chart and add them up. So this is known as the AMU, or atomic mass unit, in grams. So this is very important to know in chemistry. We're going to do some certain amount of calculations regarding those numbers. And you might need this for stoichiometry. Use what they call a mole or mole ratio. So you have two moles to one mole of oxygen, and you what they call an Avogadro's number, which is 6.22 10 to the 24th, something like that. Like 10 to the I don't know, 10 to the I don't know. We'll say 10 to the ninth, something like that. Very important, guys. Very important. Avogadro's number 6.22. Need to know that. Well, it's Avogadro's number by the Italian chemist. Avogadro. Sounds almost Spanish, but Avogadro is basically Italian. Hey, how you doing? If you guys into chemistry here, guys, this is our applied math session here we having. So I'm gonna do a lot of applied math. Welcome in, guys. Welcome in. If you guys are taking chemistry, these are some chemistry problems we're gonna go over. So this is yeah. I don't know if I want to erase this or not. It's Saturday. Happy Saturday, guys. Happy Saturday. So this is applied math problem. We study some chemistry problems. All right. So this is basic dealing with basic addition. So if you're wondering, we're gonna do what they call Charles law. I'm gonna work with what they call Charles law. basically V1 T1, V2 T2. So what we're gonna do, right? We're gonna do V1 equals T1 V2 over T2. And that's for the hell of it. So we're gonna multiply, let's say 10 cubic feet, cubic centimeters times, let's say 24 degrees Celsius divided by 24 degrees Celsius. So basically, you can cancel out these units and you have 10 cubic centimeters as your volume. Oh, yeah. Okay, 10 cubic centimeters. Welcome in, welcome in, welcome in. Hey, what's up, guys? It's like, guys, go ahead and subscribe to me. We're just doing basic chemistry problems. Keep subscribing, keep subscribing. Let's go, let's go, let's go. I'm well, thank you. I'm doing very well. Thanks for asking. Oh, thank you for subscribing. Thank you. All right. Let's get 100. Our goal is to get 100 subscribers. Let's go, guys. You need help with chemistry? Come on in. So we did a little bit of Charles law. We're just doing some basic applied problems. No calculators, guys. No calculators. Well, chemistry you can use calculators, but I'm not gonna do calculators, right? I'm gonna make the numbers manageable. So we did a little bit of Charles law. We did AMU, the atomic mass units. So let's use this what we call. If you want to convert to Celsius, it'll be 9/5. So 9/5 Fahrenheit plus 32. So we want to convert to Celsius, so we use this formula. Now if you want to convert to Fahrenheit, you want to do 4/9. No, actually not 4. 5/9. Right? So we'll do 4/9 degrees Celsius. I think minus 32. Minus 32. So let's experiment. Let's experiment. If I put 0 degrees Celsius, that'll give me 32. So that'll be 32 degrees Fahrenheit. So that's freezing. All right. Now if I put I'm going to Fahrenheit, right? We're going to Fahrenheit, we're going to subtract. I think we're going to subtract. So if I put 0 degrees here, Celsius, so I'm going to put 0 degrees Celsius, that'll be negative 32. So we got to be careful. So they make that a plus. So if I put 0 degrees, so if I put 0 degrees here, that'll be plus 32. So 0 degrees Fahrenheit, actually 0 degrees Celsius. Let me see, hold on. If I put 0 degrees Celsius, that'll be that, so that, something ain't right. So we're going for Celsius to Fahrenheit, so we'll put 0 degrees here. So that'll give me, so So we're going for Fahrenheit, right? So Fahrenheit is this. So Celsius, so 0 degrees Celsius, I'm sorry, they give me 32 degrees Fahrenheit. So I should have put Fahrenheit, I should have put Fahrenheit to Celsius, right? And so Fahrenheit to Celsius and Celsius to Fahrenheit. There we go. So Fahrenheit to Celsius and Celsius to Fahrenheit. Yes, a lot of stuff, a lot of steps, guys, a lot of steps. We want you guys to welcome in. Okay, what is it? What you want me to solve? What you want me to solve, man? Y'all keep locking it live, guys. Keep locking it live. Lock it live. Welcome to my YouTube channel, guys. We're trying to grow this channel. Keep subscribing, guys. Keep subscribing. If you guys need help with math, I'm here to help you guys. Math school semester is starting, guys. All right. So we're just solving basic chemistry problems. So we're gonna do a little algebra here. So we're gonna do a little algebra. Gotta pay attention to what's going on as well. Okay, how you doing? What's going on? I'll see you. See you. Keep coming in, guys. Keep coming in. I'm gonna keep solving problems, guys. So let's do a acid-base reaction. So we're gonna do what we call a pH value. Okay, pH. That's gonna be negative log H positive. H positive, right? And okay, H positive. So let's say we have a pH of 7. Actually 10 to the 7, right? 10 to, let's say 10 to the negative 7. So what we're going to do, we're going to figure out the log of 10 to the power negative 7. So that's going to put 7 here. Log of 10 to the 10. 7. So log 10 to 10 times 1, which equals 7. So that means out of a base, right, this will be 14 and this will be 0. So what can we say? 7, so we know that it's neutral. Neutral. Okay, which is blue. Now if it's red, very acidic. Okay? It's known as the pH scale, guys. You're in the room, keep going. You're not in the room, go ahead and end the live. So these are just some simple chemistry problems. So that's known as acid-base reaction problems, right? Acid-base reaction. So we're going to do a basic balancing of equations, guys. So we're going to do C2O equals C plus, I'll call this O, C plus O. So what we need to do to keep this balance, so this is going to be, C is good, and we got, so C is good, and we have 2 oxygens, right? We need to get 2 oxygens. So let's make this 2O, which give us C2O when you combine them, right? They switch places. And let's prove what it is. Let's prove what it is. I'll talk a little bit about reaction, right? So let's recall my knowledge. I'm testing my knowledge too. I enjoy chemistry. So I can't do flash, that's give me advanced. So you have in liquid, right? So let's say we have, it's going to be a C atom. It's going to be an oxygen atom. So when you combine atoms in a chemical reaction, right? So they're going to react. And what's going to happen is going to give up 2 electrons, right? So with 2 electrons, that's going to make that become a negative. So we say a negative 2 charge. And it's going to give up 1. So if we give up 1 electron, it's going to, so when it's give up 1 electron, that's going to be a negative 1. So these charges has to balance out. So remember, they have to balance out, right? Negative 2 right here, and it gives an electron. So when you combine them, you have a negative 2e. Right? So the negative, we call it the negative 2, then we have a negative 1. We add to it, it becomes a negative 2, we add to the other, it becomes a negative 1. So remember, the charges has to balance, which is cool, right? They switch places. That's the nature of chemical reactions. So I'm gonna show you guys the trick. So we have C and you have O2, so they're gonna switch places. So the 2 is going to go with a C at, and the 1 is going to go with an O at. And therefore give you CO2, carbon dioxide. You switch places. Why that is, I don't fully understand, but it's very, very important why you do that in a chemical reaction. Hello. No, I can prove it to you. Hi again. What's up? What's up, man? So 2 plus 2 in the real number, they give you 4. But if you look 2 plus 2, they can also give you 5 because you got the plus, right? Y'all got the addition, that's 5. If you're looking at it from a hyper-spiritual standpoint. So in the real numbers, it's 4. So there you have it. Let's keep going, guys. Let's keep going. That's my boy on the line, So we're just solving a bunch of chemistry problems that you might encounter in chemistry. Go thank me later, guys. So let's say you have a chemistry equation that involves a quadratic. So we're not going to electrons, right? Let's do. So you have the number of neutrons equals number of electrons. So let's say we have 2x plus 1. So 2x plus 1, let's say 6. So this would be neutrons, electrons. How many neutrons there are, right? So let's solve the equation. 2x plus 1 minus 1 equals 6 minus 1. So we got 2x equals 5. Okay, that's not going to work. We want to work out with whole numbers. So let's make that a 7. So hold on. Let's make that 8. Yeah, let's make that 8. So if I do what is that? That'll give me 7. Nope, we got an even number. So hold on. Let's get an even number, guys. So I gotta make this an odd number, so it cannot be an odd number. So we're gonna do 2x plus 2 equals 8. How about that? Okay, gotta be even number. So we take out 2, that'll be x plus 1 equals 8. And we divide both sides by 2, so x plus 1 equals 8, right? So that'll be 4. Right? Everything divided by 2 is 4, right? That's which makes sense. And you subtract x equals 3. So how many of these there are, right? Neutrons. How many neutrons there are? So we gotta answer the question. So n is equal to 2 times 4. 2 times 4 plus 2. That should have been a minus. Alright. Let me correct that, guys. I'm trying to make it a simple example. Hold on. So we'll do 2x minus 2 equals 8. There we go. So take out the 2. X minus 2 equals 8. So x minus 2 equals 4. There we go. So x minus 2 plus 2 is what? 6. So 2 times 6 is 12. That's not going to give me 8. So x minus 2 equals 4. I'm sorry. 4. So if I do x minus 2, the answer better be 2. There we go. How many neutrons there are? Right? So neutrons equals 2 times 2 plus 2. So it'll be 4 plus 2 equals... So 4 plus 2 so it'll be 6. I'm not getting 8. Alright, I'm gonna try a different example, guys. Let's move on. I was trying to come up with a cool example. So let's look at another example. I'll come back to that later. Okay, let's do an equation. So we do 2x plus 1 equals 7. So let's solve this right here for x. So we'll do 2x. So we'll do 1 minus 1, add the inverse property. So 7 minus 1. So 2x equals 6. By that, x equals 3. 2 times 3 plus 1 is 7. All right. Cool. All right. So that's important. Let's keep that in mind. So equals number. So we got 2 and 2. That'd be 4. Okay, so we'll do 2x minus 2 equals 6. So 4 to go to 2 times 2. So that'll be plus 6, okay. So 2 times 2 is 4, plus 2 is 6, okay. So we got a total number of electrons, right? So we got a total number of neutrons and electrons. So electrons equals neutrons. Protons. Electrons, protons, okay, let's see. Protons. So we got electrons equals protons. Total number, right? I don't know if it's neutrons, electrons. We'll make an assumption. How many protons are there, right? So go ahead and correct me, guys, if I'm wrong, right? So it's been a while. So we need to find the number of protons. So 2x plus 2 minus 2 equals 6 minus 2. So our 2x equals 4. So x equals 4. So we need to find out the number of protons. So protons, 2 times 2 plus 2. That give us 4 plus 2, 6. So the number of protons is 6 protons. There we go. It's been a while, guys. I'm sorry. It's been a while. Oh, you want to solve that? Hey, what's up? How are you? So 596 times 293. All right, so 596 times 293. Okay. All right. So 596 times 293. And you want me to solve an answer for that? You need an answer for that? I'm going to describe to you, right? If you got 6 numbers, you better have 7. If it's more than 10, you better have 7 digits. This has to do with discrete mathematics. I can tell you right now, there's a way to do this. There's a way to do this. So let's look at and we call this our common number, right? Call this K. So K1, K1, K2, 3. Let's break them up. So if I double this, right? Let's say I double this. 6, 18, 10. Okay, I'm gonna break this down. 2, double this, so we got 6, 18, 10. So this would be 6 ones, these many tens, those many hundreds. So we good on that. Put down the 0, carry that, it'll be 1, 1. And how many zeros we have? We have 1, 2. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. I'm sorry, 6. I predicted 7. All right, we're working this backwards. Again, this would be 9, so 9, 5. So 9 times 6. That's 9, 6. So we do 3 times 9 is 27, 27, 54. So it'll be 54, 81, 45. Same theory. Add the zeros. I repeat this process, you better get it 7 or 6 digits. So that's how you solve that. You're trying to trick me there, so that's how you solve that. Yeah, yeah. That was a hard problem though, man. That was a hard problem. That was tough. I'm not gonna solve the whole thing, but I'll give you the theory behind it. No, I'm a math tutor. I'm sorry. No, I'm a math tutor, tutor and teacher. I consider myself as a math tutor. That makes sense? So I can provide a theorem, okay? Whoa. I'm sorry about that, guys. Hold on. Sorry about that. Uh, oh, thank you. Appreciate that. Y'all been doing this for years, man. Thanks. Appreciate that. Okay, you too. Yeah, so let's reflect on this right here, guys. Let's reflect on this. I'm gonna tell you, I'm glad you brought this up. So I'm gonna modify the number a little bit. Okay, we're gonna talk about that a little bit. This is why advanced math is important. So we're gonna use this equation here called L equals K, K1, K2, K3. Guys, this is linear algebra, right? And so that's K1, K2, K3. 1, 2, 3. Guys, that's linear algebra. And we call this linear combination. That's all it is. Doesn't matter how hard a problem gets, you got to find a way to break it down. So that's a good question. So to solve that type of problem, right, I'm going to put it, I'm going to do 596, 293. It's not that hard. If you look at it, so wait a minute. Work backwards, right? You got to work backwards. Work backwards. You got to be able to work backwards. If you want to solve those problems in your head, you got to be able to work this stuff backwards, guys. You do really good as a teacher. Right on. Thank you. So whenever you're doing, okay, well, guys, whenever you're doing multiplication, guys, this is linear algebra, guys. This is why I teach linear algebra. So linear algebra gives you the ability to solve really complex multiplication problem of this sort. So this is a chemistry problem. This is very good. This is very important, guys. Chemistry. That's why linear algebra is so important. So wait a minute, this is linear algebra. So let's prove that proposition. Let's prove that proposition. So I'm gonna do some easy numbers, guys. I'm gonna do some easy numbers, right? So I'm gonna do 165 times 12. So what I'm going to do, right, this is gonna be my theta 1. It's gonna equals 10. And theta 2 will equals 2. If I do 10 times this, right? So I'm gonna do 10 times 165 plus 2 times 165. Which one is my K? So this is going to be my K. So K is my constant. What's varying? This and this are varying. Okay? So our variation is going from 10 to 2. So that's our variation. From 10 to 2. So it's going to change from 10s to 1s. If it was 100, it changed from 100 to 10s. So that's what's varying, right? Which makes sense. And that's your answer. That's why we talked about in the last section. You guys, we're gonna talk about it tomorrow, guys. You know, this is a very important theorem. So this suggests a very, very important theorem, guys. So this is going to invoke a very important theorem. So I'm going to show y'all this theorem. Okay. This is advanced mathematics. This is why algebra is so important. I'm going this theorem, and this is a real analysis. So this theorem is basically theorem, right? So theorem. So it's basically we got E is equal to N times N, or E is equal to K times A plus B plus C. Very important theorems, guys. Very important theorems. So this is going to invoke, so we say 1 is going to invoke, so 1 is going to invoke 2. So 1 is going to invoke 2. Yeah, good question. That was a hard question. Good question. Okay, so that's going to invoke 2. All right, so I guess we're gonna land our plane right here, guys. We're gonna land our plane. It's been a great session, guys. Thank you so much. It's been a beautiful session. I'm definitely gonna keep this up, guys. You wanna review my live videos? Go ahead, hit my live videos. And don't worry about it, guys. I'm going to put some stuff in there later. So, yeah, this is some general mathematical application for chemistry, guys. And thank you guys for participating. Thank you guys for your engagement. Remember, the school semester's coming up. We're all studying algebra at a higher level, guys. You know, everybody got their own perspective how they want to approach the subject matter. So I try to approach it from a genuine, traditional standpoint. So if you teachers out there have any suggestion, I'm open to it. I appreciate you guys. And yeah, I've been tutoring for a long time, so thank you. All right, guys, thank you so much. We're gonna close out in a few seconds. Thank you so much. All right, so I'm gonna end this live right now.